be starting with the long answer questions of oral radiology. This is one of the most frequently question that has been asked in your exam. That is, explain the working, construction and production of the X-ray machine along with the diagrams. In this whole answer, what are the main things that you will need to write is, first you will need to write about the X-ray tube machine, its different parts, how are the X-rays produced, which are the factors controlling the X-ray tube. You have to describe about the anode and cathode in detail, about filtration and collimation. You can draw the diagram that is being shown in the screen as a reference or a flow chart so that the examiner knows what points you will be covering in your answer. Let us start our answer. First, we will draw and describe the X-ray machine. So, what is the use of the X-ray machine? It produces the X-ray that passes through a patient's tissue and strikes a digital receptor or the film to make a radiographic image. The primary components of an X-ray machine are the X-ray tube and its power supply, that is positioned within the tube head. For an intraoral X-ray unit, the tube head is typically supported by an arm that is usually mounted on a wall. That is the normal IOPs that we take in our college. Next, you can draw this diagram and it will fetch you more marks. So over here, you have to draw the outer component. Then over here, you have to draw the X-ray tube, power supply, X-ray beam. You can see the X-ray beam, collimator, power supply and all. We will discuss all these further in our video. Next comes the X-ray tube. An X-ray tube is composed of a cathode and an anode situated within an evacuated glass envelope or tube. Very important. So the X-ray machine consists mainly of the X-ray tube. X-ray tube consists of cathode and anode that is situated within an evacuated glass envelope or tube. To produce X-rays, electrons stream from the filament in the cathode to the target in the anode, where the energy from some of the electrons is converted into X-ray. So this is the very easy and simple statement to understand of how X-ray rays are produced. So how are they produced? Electrons, they stream from the filament in the cathode to the target in the anode, where energy from some of the electrons is converted into X-rays. Very important diagram that you will need to draw in your exam. So over here we can see this is the anode, this is the cathode. Cathode has a electronic focusing cup. Then we can see the electrons striking and then the rays have been produced. Next comes cathode. Now we'll understand each of the X-ray tube parts in detail. So cathode. The cathode is an X-ray tube that consists of a filament and a focusing cup. Cathode consists of filament and the focusing cup. The filament is the source of electrons within the X-ray. So the source of electrons within the X-ray is filament. It is what? It is a coil of tungsten. So it is a coil of tungsten wire approximately 2 mm in diameter and 1 cm or less in length. So what are the important points in cathode that we have understood so far? First, cathode. It consists of the filament and the focusing cup. The filament is the source of electrons. It consists of a coil of tungsten wire 2 mm in diameter and 1 cm or less in length. Filament typically contains approximately 1% thorium, which greatly increases the release of electrons from the heated wire. Next important point that you need to mention, that is it. If you want, you can draw these diagrams. So it says what? It is the dental stationary X-ray tube with the cathode on left and copper anode on right. This is the cathode and the anode that is made up of copper. Now we move on to the filament. The filament lies in a focusing cup. So first is the filament. The filament lies where? It lies in the focusing cup, a negatively charged concave molybdenum bowl. So first, cathode consists of filament focusing cup. Filament lies inside the focusing cup. Its focusing cup is what? Is nothing but a negatively charged concave molybdenum bowl. The parabolic shape, it has what? The parabolic shape of the focusing cup electrostatically focuses the electrons to be emitted by the filament into a narrow beam directed at a small rectangular area on the anode called as a focal spot. So what is the work of the focusing cup? It focuses the electrons that is emitted by the filament. In filament we have 1% thorium, so that more of the electrons have been emitted. and it directs those electron rays into a small rectangular area on the anode, which is called as a focal spot. The electrons move to this focal spot because they are both repelled by the negatively charged cathode and are attracted to the positively charged anode. That is the reason that the electrons move to the focal spot. Now we move on to anode. So anode consists of what? It consists of a tungsten target embedded in a copper stem. The purpose of the target in an X-ray tube is to convert the kinetic energy of the colliding electrons into X-ray photons. So that is the main work of the anode. Anode consists of what? A tungsten target that helps in converting the kinetic energy of the electrons into the X-ray of the photons. The target is made of tungsten, very important, an element that has several characteristics of ideal target material. Why it is made up of tungsten? And you have to mention these points. High atomic number allows for efficient X-ray production, high melting point, that is 3422 degrees Celsius to withstand heat, high thermal conductivity, and low vapor pressure. So why tungsten is selected? Because of its high atomic number, high melting point, high thermal conductivity, and low vapor pressure at the working temperature of an X-ray tube to help maintain a vacuum in the tube at high operating temperatures. Hence, a low vapor pressure is required. As we have learned, the anode, it consists of the tungsten target. So the tungsten target is what? It is typically embedded in a large block of copper. Why? Because it functions as a thermal conductor to remove heat from the tungsten, reducing the risk of the target melting. So we have learned the reasons why tungsten has several characteristics that makes it the ideal target material, and the target material is embedded in a large block of copper. Now we move on to the another part of anode, which is the focal spot. So the focal spot is the area on the target. It is on a tungsten target to which the focusing cup of the cathode directs the electrons and from which X-rays are produced. The size of the focal spot is important. Why? Because a smaller focal spot yields a sharper image. But there is a limitation to this, because once we reduce the size of the focal spot, there is a lot of heat generation. So to overcome this, two techniques and methods can be used. One is the stationary anode and another is the rotating anode. No need to write in detail the explanation of the stationary and the rotating. Just mention that to overcome the excess of the heat which has been produced by the focal spot, two configurations can be adapted. One is the stationary anode and another is a rotating anode. With this, we complete about the X-ray tube two major parts, that is the cathode and the anode. You can draw this diagram if you want, but it's not important. The earlier diagrams of the X-ray tube machine is important. Next is the power supply. The X-ray tube has two transformers that lie within an electrically grounded metal housing called the head of the X-ray machine. The primary functions of the transmitter or the transformers are what? They provide a low voltage current to heat the X-ray tube filament. That is the main part. That is the important thing of why we need a transformer, because they will provide a low voltage current to heat the X-ray tube, to generate high potential difference to accelerate the electrons from the cathode to the focal spot on the anode. So power supply, two important things that you will mention. One, it consists of two transformers that lie within the head of the X-ray machine. What are the functions? Low voltage current to heat the X-ray tube, and NS generate a high potential difference to accelerate the electrons from the cathode to the focal spot on the anode. This is a very easy it seems to be difficult, but it is not difficult. See, you can just draw X-ray tube. This is the anode, this is the cathode. Then you just have to draw, one is the kilovoltage and one is the milliampere. Over here, you can see a high voltage transformer. Transformer, what does it help? It will help to produce a low voltage current so that there is not excess of heating on the X-ray tube. So over here is the voltage produced by the transformer, which is low. That's why no excess heating is present. So you can draw this diagram. Next, we move on to the X-ray tube controls. That is the tube current, and the tube voltage. Two important things. During the X-ray production, electrons produced at the filament are attracted to the anode. This flow of electrons from the cathode to anode generates a current across the X-ray tube, and it is called as a tube current. What is tube current? The current that has been generated when there is a flow of electrons from cathode to anode. The magnitude of this current is regulated by milliampere control. For many intraoral dental X-ray units, it is typically fixed to 7 to 10 milliampere. This is important. So, important things that you need to mention over 7 to 10 milliampere. And what is tube current? Next, we move on to tube voltage. High voltage is required between the anode and the cathode to give electrons sufficient energy to generate the X-rays. The kilovolt kVp selector adjusts the high voltage transformer to boost the peak voltage of the incoming line current. Typically, intraoral, panoramic and cephalometric machines operate between 50 to 90 kVp. Once again, the value is important: 7 to 10 milliamperes, 50 and 90 kVp. Next comes the alternating current X-ray generators. This is not important and no need to mention this in your LAQ because there are many more topics that needs to be mentioned. Next, we move on to the timer. So we discussed about the voltage, the milliampere current, that is the tube current. Then comes the timer. A timer is built into the high voltage circuit to control the duration of the X-ray exposure. The electronic timer controls the length of time that high voltage is applied to the tube and thus the time during which X-rays are produced. However, before the high voltage is applied across the tube, the filament must be brought to the operating temperature to ensure an adequate rate of the electric emission. Subjecting the filament to continuous heating and normal operating current shortens its life. To minimize filament damage, the timing circuit first sends a current through the filament for approximately half a second to bring it to the proper operating temperature and then applies power to the high voltage circuit. In some circuit designs, a continuous low level current passing through the filament maintains it at a safe low temperature, further shortening the delay to prevent the preheat. That is to prevent the preheat. For these reasons, X-ray machines may be left on continuously during the working hours. So, in short, you can just mention that to bring the filament to continuous heating at a normal operating current will shorten its life. That's why to minimize the filament damage, the timing circuit will first send a current through the filament for half a second to bring it to the proper operating temperature and then it will apply the power. Next, we move on to the production of X-rays. So up till now, we have learned about the X-ray tube machine, about cathode, anode, different parts of cathode and anode, how are the different parts function. Now we move on to the production of X-rays. Occasionally, the electron's kinetic energy is converted into X-ray formation of Bremsstrahlung radiation and characteristic radiation. So, what is Bremsstrahlung radiation? The photons are the primary source of radiation from an X-ray tube. That we all know. Bremsstrahlung means breaking radiation in German. So, most high-speed electrons pass by the tungsten nuclei with near or wide misses. In these interactions, the electron is attracted towards the positively charged nuclei. Its path is altered towards the nucleus and it loses some of its velocity. This deceleration causes the electron to lose the kinetic energy that is given off in the form of X-ray photons. The closer the high-speed electron approaches the nuclei, greater the electrostatic attraction between the nucleus and the electron, and the resulting photons have higher energy. So you have to learn this, write this, very important. The efficiency of this process is proportional to the square of the atomic number of the target. We have the tungsten target because why? Because of its high atomic number, that is 74. Very important to draw these diagrams. See, the radiation is produced most often by the passage of an electron near the nucleus. Near the nucleus, the electron is being passed, which results in electron being deflected and deaccelerated, or less frequently by the direct hit of an electron on the nucleus in the target. There are very less or rare incidents when the electrons from the filament directly hit the nucleus of the target atom. When this happens, all the kinetic energy of the electron is transformed into a single X-ray photon. And this is the explanation for the same. You can draw this diagram. It is a graph that has the photon energy and the relative number of the photons that is required. Next, we move on to the characteristic radiation. Characteristic radiation is what it contributes only a small fraction of the photons in an X-ray beam. It is made when an incident electron ejects from an inner electron from the tungsten atom. When this happens, an electron from an outer orbital is quickly attracted to the void in the deficient inner orbital. When the outer orbital electron replaces the displaced electron, a photon is emitted with the energy equivalent to the difference of the binding energies of the two orbitals. The energies of the characteristic photons are discrete because they represent the difference of the energy levels of the specific electron orbitals and are the characteristics of the target atoms. See, what means the characteristic radiation? Like an electron, it ejects from an inner orbital. You have to draw these diagrams. So an electron, it ejects from the inner orbital, then some other electron from outer orbital replaces that inner orbital. So there's a difference of energy, and this is called as a characteristic radiation. Now we move on to the factors controlling the X-ray beam. There are 3 to 4 factors which control the X-ray beam. First is the timer, exposure rate, that is the milliampere current, energy, that is the kilovoltage, shape, that is nothing but collimation, and intensity. So these are the factors that control the X-ray beam. First, we'll start with the exposure time. Changing the exposure time, typically measured in fractions of second, modifies the duration of the exposure and thus the number of photons generated. When the exposure time is doubled, the number of photons generated at all the energies in the X-ray emission spectrum is doubled. Very important point that you will need to write and draw this graph. So what does the graph indicate? There is a spectrum of photon energies generated in an X-ray machine showing that as the exposure time increases, kilovoltage and the milliampere settings held constant. Even if you're increasing the exposure time, the settings remain constant, so the total number of photons. The mean energies, that is the dotted line, this is the mean energies in both, and the maximum energies of the beam are unchanged. Then we move on to the milliampere setting, that is the MA of the tube current. Like the effects of exposure time, the quantity of the radiation produced by an X-ray tube, milliampere current, it will tell you the quantity of the radiation. That is, the number of photons that reach the patient is directly proportional to the milliampere setting. Over here, in exposure time, what is the important point that you need to write is when the exposure time is doubled, the number of photons generated at all energies in the X-ray emission spectrum is doubled. In milliampere rate setting, it tells us about the quantity of the radiation, that is the number of photons that reach the patient. As the milliampere MA setting is increased, more power is applied to the filament, which heats up and releases more electrons that collide with the target to produce the radiation. Thus, as with the exposure time, doubling the milliampere setting will double the number of photons. Very important and question that an answer that you need to know. Like sometimes this question is asked in your MCQs, that what will happen if you're doubling the milliampere setting? What changes you will see? You will see that the number of photons produced are also getting doubled. You can draw this graph. It shows what the spectrum of photon energies generated in an X-ray machine, showing that as the milliampere setting increases, as the milliampere setting is increasing, the current is increasing, KVP and the exposure time remains constant. The exposure time is constant and this is also constant. Now we move on to the tube voltage peak. Increasing the tube voltage peak increases the potential differences between the cathode and the anode and increasing the kinetic energy of the electrons. The greater the energy of electron, the greater the probability it will be converted into an X-ray photon at the target. So, if we increase the tube kilovoltage, what will happen? There will be increase in the number of photons generated. Mean energy of the photons increase. The maximal energy of the photons increase. See, you can draw this diagram. What is it showing? This graph, the spectrum of photon energies generated in an X-ray machine, showing that as the tube kilovoltage is increased, this is 80, this is 80, 90 and 100, as that is being increased, there's a corresponding increase in the mean energy of the beam, the total number of photons emitted and the maximal energy of the photons, increase in the mean energy, number of photons and the maximal photons. So in tube voltage, what are the points that you need to remember? Once we increase the tube voltage, number of photons generated will be increased. Why? Because the mean energy of the photon is increased and the maximum energy of the photon is increased. The term beam quality refers to the mean energy of an X-ray beam. This is sometimes asked in your MCQs. Next, we move on to the filtration and collimation. Although an X-ray beam consists of continuous spectrum of X-ray photon energies, only photons with sufficient energy to penetrate to the atomic structure and reach the image receptors are useful for the diagnostic radiology. Low energy photons that cannot reach the receptor contribute to the patient risk but do not offer any benefit. Consequently, it is desirable to remove these low energy photons from the beam. This removal can be accomplished in part by placing a metallic disc, that is a filter, in the beam path. So why do we need a filter? Because not all of the X-ray photon energies that are produced will penetrate through the structure and help us in the radiology. There will be some that are not useful and that can be a risk to the patient. So in order to lower the risk to the patient, we will place a metallic disc, that is a filter. A filter preferentially removes low energy photons from the beam but allows high energy photons that contribute to making an image to pass through. Then there are two types of filtration: inherent filtration and added filtration. Inherent filtration is what? It consists of the materials that X-ray photon encounters as they travel from the focal spot on the target to form the usable beam outside the tube enclosure. These materials include the glass wall of the X-ray tube, the insulating oil that surrounds many dental tubes, and the barrier material that prevents the oil from escaping through the X-ray port. The inherent filtration of most X-ray machine ranges from equivalent of 0.5 to 2 mm of aluminium. You have to mention this. Inherent filtration, what is inherent filtration? What are the materials? That is the glass wall of the X-ray tube, the insulating oil that surrounds the many dental tubes, and then you have to write the range, that is 0.5 to 2 mm. Added filtration may be supplied in the form of aluminium discs placed over the port in the head of the X-ray machine. Aluminium discs that are placed over the port in the head of the X-ray machine. Total filtration is the sum of inherent and the added filtration. So filtration, inherent and added, and that the total filtration is nothing but the sum of both. Collimation. And yeah, one more point. In your added filtration, you have to write the size equivalent is 1.5 mm of aluminium for a machine that is operating at 70 kVp and 2.5 mm aluminium that is for a higher voltage. So in your inherent 0.5 to 2 mm, in most of the X-ray machines, in your added filtration, if it is up to 70 kilovolt, then you have to use 1.5 mm of aluminium, and if it is higher than that, then you have to use 2.5 mm. Next we move on to is collimation. Collimator is a metallic barrier with an aperture in the middle used to shape and restrict the size of the X-ray beam and the volume of the tissue irradiated. Round and rectangular collimators are most frequently used in your intraoral radiography. The two types of collimator most frequently used is your round and rectangular. What is the use of collimation? It is a metallic barrier that has an aperture in the middle which is used to shape and restrict the size of the X-ray. Shape and restrict the size of your X-ray is because of the collimator. Dental X-ray beams are usually collimated to a circle 2.75 inches, that is 7 cm in diameter, at the patient's face. These things are very important because the values, if you write in your exam, you will fetch more marks. A round collimator is a thick plate of metal with a circular opening centered over the port in the X-ray head through which the X-ray beam emerges. Rectangular collimators further limit the size of the beam to just larger than the intraoral receptor. So in collimator, just write there are round, rectangular, the use of the collimator, and the diameter of the round collimator. Next, we move on to the inverse square law. So what is the inverse square law? Just write this. The examiner will understand that you know, where I is the intensity and D is the distance. If you want, you can draw this line. Like you can just show a normal projector and the screen if you want. Then comes the interactions of X-rays with matter. So what are the different types of interactions of the X-ray? So first is the photoelectric absorption, Compton scattering, and coherent scattering. So these are the three different types of interactions of the X-ray. See, first 9% there is no interaction. Most important type of interaction that takes place is your Compton scattering. Then comes a photoelectric absorption, which is roughly around 27%, and coherent, which is about 7%. Yes, so first we'll start with the photoelectric absorption. If you just draw the diagram and explain it in your own words, the examiner will know that you know the answer. So what is a photoelectric absorption? See, a photoelectric absorption occurs when an incident photon gives up all of its energy to an electron, which is ejected from the atom, a photoelectron. The incident electron ceases to exit at this point. The ionized atom now has an electron vacancy in the inner orbital. An electron from a higher energy level fills up the vacancy and emits the characteristic radiation. All orbitals are subsequently filled, completing the energy chain. That is your photoelectric absorption. It is roughly around 27% of the interactions of the dental X-ray beam. Draw this diagram and explain your photoelectric absorption. Next, we move on to Compton scatter. It occurs when a photon interacts with an outer orbital electron. 57% of the interactions in the dental X-ray beam exposure involve Compton scatter. See, Compton scattering occurs when an incident photon interacts with an outer electron. Incident photon, it interacts with the outer electron, producing a scattered photon of lower energy than the incident photon. This is the scattered photon. It is of lower energy than that of the incident photon. And a recoiled electron is ejected from the target atom. The new scattered photon travels in a different direction from the incident photon. So this is all about Compton scattering. Next, we move on to is coherent scatter. Coherent scatter has different names. If you want, you can learn these names. So what is a coherent scatter? Coherent scatter results from the interaction of a low energy incident photon with a whole atom, causing it to be momentarily excited. So low energy photon will hit the atom, it will excite the whole atom, and after this interaction, the atom quickly returns to the ground state and emits the scattered photon of the same energy but at a different angle from the path of the incident photon. So very important, coherent is what incident photon hits, it momentarily excites the whole atom, and then an incident photon is generated, that is, it is released but at of different energy. Coherent this is coherent. Compton scattering is what an incident photon hits, then it will scatter a photon of lower energy and a recoiled electron is also ejected. That is only of Compton scatter, that is about 57%. Then we move on to photoelectric, 27% interactions. What happens? There is an incident of photon that hits, then that after hitting the atom, the photoelectron gets ejected, there is a vacancy, then from some outer orbital, a higher energy level electron, it fills up that vacancy. That is a photoelectric absorption. So in this whole answer, we are concluding the answer. So first you have to mention about the X-ray tube machine, the X-ray tube machine parts, that is the anode and the cathode. What are the different parts of anode and cathode? Then you have to mention about the production of the X-rays. What are the factors that determine the production of the X-ray? That is the timer, the milliampere current, the tube voltage. Then you have to write about the different types of absorption, that is the interaction of the X-ray, photoelectric, coherent, Compton. Try to draw maximum diagrams as possible. The answer is very easy. You should just know your basics very well. Kindly go through all the highlighted points and all the marked diagrams. This is more than sufficient and enough for you to get a good score in your long answer questions. Thank you.